We're continuing with our fraction class. Just a quick review here. It has two private variables. A represents the numerator, B represents the denominator. They're both of type int. We have a constructor, which is the default constructor, which will assign a value of 0 and 1 to the numerator and denominator. We have a parameterized constructor here where you can pass in what you want for the numerator and denominator. If you want to represent a whole number rather than passing in a numerator and then a denominator of 1, you can just pass in an integer and we will set the denominator to 1. And then there's a copy constructor which takes an existing fraction and makes a copy of it. So we're passing in x and we copy x's numerator into this is numerator, and we copy x's denominator into this is denominator. And then we have four arithmetic operators: times, divided by, plus, and minus. None of them change the invoking object. All of them create a new result and return the result, which is actually a pointer to the result. Okay. Then we wrote six relational operators, and we really only had to do much work on equal, and that's not a whole lot of work, and greater than. And then we used those to write the other ones. So we're building on the work that we already did. And then we have a two-string. Okay. Now we have a couple of other things that I want to add for sure. I want to be able to tell a function to reduce itself. So public, and this is going to be void. It's not going to return anything. It is just going to reduce the existing fraction function. So we don't have to pass in any arguments. It's just going to look at A and B, and it is going to find the greatest common divisor of A and B, divide by that, and then it will reduce the fraction to its lowest terms when that happens. So we need to find an algorithm for the greatest common divisor. So I'm going to go look for one on the internet. So here's what I found on the internet, and it is going to require a little bit of modification. So we don't use the word function. This is pseudocode. It's going to return an int, and we don't need to worry about making this public necessarily. Actually, I'm going to make it public for right now. Return int, and the name of it is going to be GCD. We're going to pass in an integer called A. We're going to pass in an integer called B. And then the body of it is going to be this while loop and the return statement. Now we've got some illegal characters here. I want to say B is not equal to 0. And so I have to delete that not equal symbol and put not equals the way it's done in C# and C. Not sure about the red wavy line there. I'm just going to try copying it, replacing it with a, yeah, that's not working, but we'll figure it out. So let's put this is the body of the loop here. We do not use a colon equals for our assignment operator. Some languages do. C does not. So we just use a regular equal sign, and let's put a semicolon on the end of each one of these. Okay. And the mod operator in C# is the % sign. And T needs to be declared. So int T equals 0. Okay. Now I'm thinking this ought to work. Let's do Control K, Control D, and it is still not working. Well, I had to reformat that by hand because my screen recording software intercepts the Control K, so it never gets to my program. So this is the code that I copied, and I want to check it and make sure that it works. So that's why I made this public. So we're going to go back over here to our program, and we're just going to try a few things here that we know the answer to. So console.writeLine And I'm going to A dot and then GCD. And let's find the greatest common divisor of 5 and 15. So that should be 5. Let's do and we'll make one of the numbers a prime number. We'll do 10, 37. 37, we should get 1 for that. Let's try one more. And let's try something like 75, 100. We should get 25 for that. Okay. So we should get 5, 1, and 25 as our last three numbers here. Let's run it and try and see what we get. 5, 1, and 25 are what we're expecting. 5, 1, 25. So apparently the algorithm I found was correct, and I implemented it correctly. So I'm going to make that private again, though, which I think is the default. If you're not sure, you can put private in front of it. So in order to reduce a fraction, I need to find the greatest common divisor of the numerator and denominator. So let's declare an integer variable, and I'm just going to call it div for my divisor equals the greatest common divisor of this dot A and this dot B. Then I'm going to let this dot A equal this dot A divided by, divided by my divisor, and this dot B is going to equal this dot B divided by my divisor again. Okay, and I'm not returning anything. This is a void function, so it's just going to reduce. It's going to change the value of the numerator and the value of the denominator for the fraction that invoked this method. Now, I also want to do one called reduced, and that is going to return a fraction. And the difference between these two is that reduce is void, and it changes the invoking fraction itself. This one returns a fraction that is the reduced version without actually changing the numerator and denominator of the invoking fraction. So we're going to have to create a new one. So fraction result equals new fraction. Then we're going to do our same thing here. We're going to do the same code we did up above. But instead of changing this, I'm going to change result. And then I return result. That should get rid of my red wavy line, and it does. So let's go back and write some code to invoke these functions. So let's set A equal to new fraction, and we'll do 10, 30, and that should reduce to 1/3. Then if I print out A, after reducing it, I should get 1/3. Now let's do that again. Let's take the same code here, so we'll set it back to 10/30 again. And what I want to do this time is I'll do another fraction. We've been using C to hold our answers here. So we'll do C equals A dot reduced. That should not change A. So now we can print out we'll print out what's in A first. It should not be changed. And then we'll print out what's in C, and that should be 1/3. Okay? And since GCD is no longer public, I'm getting errors down here from the last code that I put out. Now let's go ahead and run that, keeping in mind we should get A does get reduced, it does get changed, so we should get 1/3. Then we set it back to 10/30ths, and it does not get reduced, but C does. So our last three options should be 1/3, 10/30ths, and 1/3. One-third, 10/30ths, and 1/3. So that's looking good. In our next video, we will take a look at doing a little bit of error checking inside of some of our functions.